forgot what grid is.
Okay, so here's what it would look like if you did the boundaries. You'll see it goes from this boundary up and then over to the other boundary. So this boundary is that boundary, that's the distance, right? And so these things are centered right where these lines are at. They come straight from those lines. You also could have done it this way using the limits, and then the limits should be centered in the middle. Does that make sense? Oh, but they shouldn't touch. Uh-oh. So these shouldn't touch. So this is wrong. There should be little tiny gaps between them. So that's what that would look like. Okay. Good.
Okay.
Hey.
We did it, but it didn't.
Okay. Next. All right. So on to new stuff. In later chapters, we're going to be referencing this thing called the normal distribution. There's some key characteristics about it. Most importantly, it has a bell shape, right? So it's a bell-shaped curve. In other words, the frequencies start off low, they go up higher, they max out in the middle, and then they drift off and they go low again. It's symmetric, one side to the other. So it's roughly, the left side is roughly the mirror image of the right side. Here is that bell-shaped normal curve. See, it sort of starts off low, drops up to the top, and then comes back down. They're roughly, same on the left and the right. The next one is a uniform curve. So it means uniform means the same, right? So they're roughly all the same, roughly. And we have right skewed and left skewed. So right skewed is when you take your data and it's kind of pulled off to the right. See, it kind of dribbles off to the right. That's the way I kind of remember it. Left skewed, you can see it sort of dribbles off to the left. That's the left skewed. So when it kind of, the part that kind of dribbles off, that's the side that's how you tell them apart. That's the left skewed. Because I get left and right confused all the time. That's the only way to kind of think of it, is it kind of dribbles off to the left if it's left skewed. Yeah?
My stats teacher taught me last year, you ski down the right of the hill and you ski down the left of the hill.
Oh, sweet! I love that. Left skied.
Yeah.
Nice. Oh, that's brilliant. Perfect. So yeah. So right skewed means you skew to the right. Left skewed means you ski to the left. It's left skiing. That's awesome. Who's your stat teacher?
Livermore High.
Yeah. Yeah, I know. All right, no worries. We're also going to talk about other types of graphs. Frequency polygons, ogives, bar graphs, Pareto charts, time series graphs, pie graphs, dot plots. We're not going to do 7 leaves. If your computer is not on, turn it on now. The way you turn it on is in the bottom underneath the computer, the bottom right-hand side, kind of right below where it says bang, when it says bang and Olufsen, right below the bang on the bottom. There's a little button. Push the button down. Below the bang. Turn it on. How do you log in? Under student, you just hit enter. There's no password. Good. Everybody have it? All right. So. Now, first off, let's talk about frequency polygons. Those use the class midpoints. So this should be in your notes, right? Frequency polygons use the class midpoints. And frequencies, or relevancies. Usually frequency of the class. You're in your notes. We're in our notes. Page 2 notes from last class. Finishing those up. So the last thing we were just working on, the next page, right? You guys use okay. All right. So what you guys will notice, frequency polygons are kind of useful because really they're just like histograms. Why are they just like histograms? Because if I were to draw something, say my boundaries, if this is my midpoint, if 8 is my midpoint, that means my boundaries from here were from here to here. Does that, you guys kind of follow me? And my histogram would just be like that. So this is exactly the same. If I were doing a histogram, right, the midpoint's in the middle, the boundaries are kind of halfway between the midpoints, it would just be like this. So the frequency polygon and the histogram give the exact same information. There really isn't any difference between them. Oh, please note that they are anchored on the ends. So you have to like have a, won't really come up, I don't think. It might come up in your lab possibly, but you know, it's basically, if I were to take a histogram and find the midpoint smack dab in the middle, I just put a dot smack dab in the middle of each bar and just draw a line between them, that'd be my frequency polygon. It's same. It's basically the same graph. It's only it's using lines instead of bars, and then obviously using midpoints instead of using boundaries. Relative frequency graphs. Sometimes we want to use relative frequencies instead of frequencies. That's usually when we're comparing data from different surveys that are not the same size. So you might take in a survey of 1,000 people, and if you want to compare that to a frequency polygon of a group of 100 people, everything's going to be higher than 1,000. It doesn't make sense. So instead of comparing numbers, frequencies, you probably would use relative frequencies, right? Percentages, with the percent in each group. So let me show you what a relative frequency graph looks like. Like that. So this is a relative frequency polygon. What you'll notice is the only thing that changes, everyone stare at the graph. Stare at the graph itself. That's a relative frequency polygon. This is a regular polygon. Nothing changed. The only thing changed was the stuff on the side. Right? The frequencies changed from numbers to being, stare at it again, to being decimals, just to being percentages. That's the only thing that changed. Otherwise, they're exactly the same. Histograms can also use frequencies or relative frequencies. You know, this is a relative frequency one where you have the percentages along the side instead of the actual frequencies. Either one's acceptable depending on which situation you want to use it in. You can use either. Ogives, aha! Ogives are different. These use the upper class boundaries and cumulative frequencies. Or cumulative relative frequencies, either one, but cumulative. So ogives use upper class boundaries and cumulative frequencies. Is that not my notes? Oh, you said the right part. I should have made you guys write more than that. Really? I need to change the note to make you guys write a little bit more. Okay. So it's important to know that, like as in it might be on your exam. Okay. Scatter plot, scatter diagrams. Right, you guys have seen this before. It's when you know two things about each subject and you graph them, one along the x-axis and one along the y-axis. So here, for example, I know two things about each person. This guy, this one right here, that's one guy. What do I know about him? Well, I know his arm circumference is about 138, right? 138 centimeters. And his waist circumference is about 130 centimeters. And his arm circumference is about maybe 43. So see where I'm getting this from? So kind of figure out, he's at about here, 138. And he's roughly maybe 40, I don't know, 42, 43. Say 43. So that one dot, each dot represents a person and the two pieces of information about them that you know. Their waist circumference, like this person has a waist circumference of like 78, and an arm circumference of like, I don't know, 27. Good? Okay. Scatter plot. Bar graphs. So those can either be, so histogram is a type of bar graph. Bar graphs use vertical or horizontal bars to represent the frequencies. So they can either go up and down like this, or they can go sideways. Right? This is a vertical one where it goes sideways. You can go either. You could also have compound or multiple bar graphs, where you have two different groups and you compare them side by side with the bar graphs. Sometimes effective. And then Pareto charts. Okay, these will come up also as well. So Pareto charts are only for categorical data. They're bar graphs, but they're bar graphs where you've rearranged the data from most frequent to least frequent. So you can only do that with categories, because if it's numbers, you can't move the numbers around, right? You can't have 3 before 1 and 5 between 1 and 3, right? It's got to be, if your data's numbers, it's got to stay in order. But it doesn't matter. You can have train in front of bus, in front of walk. You can put these in any order you want. So with categorical data, we can have a Pareto chart where we rearrange the data again from most frequent to least frequent. So make sure you know that, because it will come up. Okay. And then we have time series graphs. That shows how a variable changes over time. Time is pretty much always on that x-axis. And I'm sure you guys are familiar with those. We also have time series graphs. Sometimes you can show more than one thing on there as well. And then we have pie graphs. All right, so a pie graph is where you take a circle, a pie, and you divide it into sections. And the amount that's in each section is proportional to the total amount in that class. Right? How do you figure out how many degrees are in each one? Well, how many degrees are there in a circle? 360 degrees. So you ever heard someone doing a 360? It's because they do a full rotation, right? If he does, a little skateboarder does a full rotation, that's a 360. So 360 degrees in a circle. What you do is you take the percentage in that class, the relative frequency, you multiply it by 360 degrees, and that tells you how many degrees are in each section of the circle. All right, a dot plot. That's a statistical graph where each, I think this one is not on your list, but I'm throwing it in here. It shows kind of how data sort of spread out. So they'll have above each number, like here's 70. One person, there's one dot above it. So one person was at 70. Here's 80. There's 3 dots above it, so 3 people were at 80. It's just another way of showing things. So we're going to try doing some dot plots. Let's see. Pass these down and then pass them over to the other side. You pass these down. Leave them face down. Do not look at them. Don't cheat. Face down, face down, face down. Face down.
Yeah. So the whole time drop.
Plug out for me.
Leave them face down. Okay. So we're going to do a random rectangle activity. The back side of this sheet has 100 rectangles on it. Each rectangle represents a house, and the number of squares are the number of people in the house. So this one here is a house with 8 people in it. Good? 8 squares. So what you guys are going to do, don't look at the paper until you're told to look, so don't look. What I'm going to have you guys do is flip the paper open for 10 seconds, and only 10 seconds, and your task is to try to guess what the average number of people per house is. The average number of squares per rectangle is. 10 seconds. And then I'm going to have you write it up here. So average, just round your average to the nearest half and put it in here above your spot. So you know you can go halves in between, it's fine. So when you're done, figure out what your average is, and just come up here and put a dot in the dot plot, you know, either in the half part or the regular part above your number. Okay. Good? There's 2 pens. Ready? 10 seconds. Ready, go. And ignore the numbers. Stop. Flip it back over. You're just trying to guess how many. They're all numbered later on for whatever reason. Don't worry about that. You're just trying to guess, on average, how many squares there are per rectangle, right? So once you have it, put a dot plot, put a dot above this to the nearest, to the nearest half, right to the nearest half. There's 2 pens. So turn them over now, 30 seconds. Choose 5 that you think are representative of the population and circle them. Got plenty of time. Got another 20 seconds left to do this. So choose 5 that you think are representative of the population and circle them. 15 more seconds to choose your 5. Got plenty of time. Choose 5 that you think are representative. Okay, 5 more seconds. Okay, so you should be done choosing your 5 at this point. Now, add up how many are total, right? Add up how many in each. How many you have total and divide by 5. And then average those 5, the 5 that you chose. And then come up here, right up to the nearest half. Come up here and put another dot up there for that. Okay, so this is our results over there. Okay, so it looks like pretty much we picked about 9. Does that seem about right? If you kind of average them all out, looks like about 9. Would it surprise you to know the actual average, I believe, is 7.47. So it's fairly common. Typically, hey guys, people kind of focus on the larger ones, so people tend to overestimate these things. It happens a lot when people are trying to randomly pick things, you know what I'm saying? It's hard for us to really, truly randomly pick stuff. So we're going to try, what do you think a better way of trying to get a true, fair sort of way of selecting them? These guys are all numbered from 1 to 100. What would be a fair way of selecting them? What do you guys think? Talk to each other for 30 seconds. You can find a fair way of picking 5 to sample.
The middle was like 5, from 10 to 20.
All right, so any ideas? How can we want to ensure that every house has an equally likely chance of being selected? Any ideas? Yeah.
Well, they're all numbered, so you could just put them in a random number generator.
Yeah, random number generator. So we're going to do just that. So everyone, get your phone out, or you can use your computer, either one, and Google random number generator. Random number generator. So this is what comes up on my screen when I do that. You guys get something similar? Yeah. Okay, so here's the thing. Hey, guys, heads up. We want to choose a number between what? Between what and what?
1 and 100.
1 and 100. This says 1 and 10. You gotta change it. Right? Everyone with me? Yeah. One number between 1 and 100. So change it. And then you're gonna do this. You're going to pick. You're gonna generate 5 numbers between 1 and 100, and you're gonna write them down on the back of your paper. Then you're going to flip over your paper, you're going to figure out, you're going to find those numbers and figure out how many are in each of those houses. So like say I picked house 69. Everybody with me? So I'm going to flip over this sheet and find house 69. House 69 is right here, and it's got 18. It's got 18 on it. Do you see what I'm saying? So that's one of the houses I picked to average. Then I'm going to pick another one. I'm going to do that 5 times. And I'm going to find those 5 house sizes and I'm going to average them. Good? So generate, randomly pick 20, 88, 70. So randomly choose 5 houses from 1 to 100. And then write down what size each of those houses is. And average those 5.
All of mine are small, dude.
When you're done, write your numbers in up here. Again, round it to the nearest half.
Go to the boxes and you know how all the boxes are numbered? Yeah. Just find out how many boxes are in each of those numbers. Yes. And then find the average.
So from looking at our data, I think it actually might be true. I think it actually might be 6 point something. I got to check with the person who did this, but I think that I pulled the number 7.5 off online off of somewhere. So it might be that. Okay. Good deal. So what that kind of should show you is that you really want to be random, like truly random. Whenever you're trying to pick out data, you don't want to try to do what you think is random, because what you think is random is not necessarily truly random. Does that make sense? Yeah. It's subject to being, our misinterpretations. All right, so we are going to skip lab problem 4 or 5. 4 or 5. 4 and 5. Yeah, we're skipping 4. Yeah, cross it out. Move on to lab problem 6. Okay. We are going to make a pie chart. Oops. Oh, you can't see that. So we're skipping lab problem 4. We're moving on to so just try to skip across lab problem 4. Move on to lab problem 6. We're going to make a pie chart for this. We're going to do the easy way. We're going to use Excel. Let it help us out. So, but first let's decide how much is in each of these categories. We're consistent. So this bottom one, the tungsten, what percent do you think is in there? What do you think that is? 1%? Sure. 1%. Sounds good. How about the blue one, the next one? 2%? 3. 3? I'll go 3. 3 seems good. The next one? 5%? Sure. The green one? 10%? Seems reasonable. Next one?
25.
Wow. Okay, so here, I'm going to go with something in the middle, like 18%. Seems like we had 15s, we had 20s, we had, well, it could have gone 7. But we'll go with 8. Yeah, I'll go with, that's right. So that's good enough. So if we add those up, we get 28, 37. So this is with 63% left for this guy. Good? Okay. So, what you're going to do is you're going to open up Excel. So Excel, first of all, write these numbers down across the top on your sheet. Write them down, because this is going to go away in a minute. and then open up Excel. If someone has already typed stuff in for Excel, highlight it and hit delete and delete it. All right, you got to practice doing it again. So I was writing these down, right? I'm going to turn the do stop. Yeah?
The X thing at the bottom.
Okay, so now everybody should find the little green X at the bottom of your screen right here. Look up. You guys see a little green X right down here? That's Excel. Click on that. And then pick the very first one. That is blank workbook right here. Again, if someone's already typed stuff in here, then just highlight it, left click drag, highlight it, and hit the delete key, delete it. Okay, you're going to type in all the information. So the first one was what? ST, it was what? It was what? Yeah. The top one? Shrink. Shrink. Oh, sorry, let me make it bigger. Okay, so you're going to type in shrink. How much was shrink? 63. So I'm going to put in 0.63. Everybody good? What was the next one? Velocity? Velocity? 18%, 0.18. Weld. How much is weld, guys? 10%, 0.10. Next one? Shell. Okay. So is everybody with me so far? Yeah. Shell is 5, was it 5%? 5%? That 5% is not 0.5. 5% is 5 cents. How would you write 5 cents? 0.05. Make sure you do that right, or else you're going to get something totally screwed up. Again, remember 5 cents. 5% is 5 cents. 0.05. Next one?
Hard alpha.
Alpha? What alpha?
Hard alpha.
Hard alpha. 0.03. 3%. 0.03. And last one, tungsten. 1%. So everybody do what you should know for that one. 1 cent. Okay. So who has them all typed in already? Okay. When you get them all typed in, highlight all of them. Left click drag to highlight all of them, right? Left click, highlight them all. And then adjust them. Then go to insert. Insert, and then you'll see kind of in the middle of the thing, you'll have all these little charts. And you'll see a little circle one. So click on the little circle one, you'll see right into that first one, 2D pie right there, boom. Insert, and in the middle you'll find the little circle. All right, so then draw the picture on your sheet, on your paper.